A plastic ball has a mass 4 grams and a volume 20 cubic centimeters. There is a crack in the ball's surface. The ball is placed in a bath of water. The ball is placed in a bath of water. The water leaks into the ball without changing the volume of the ball. Eventually, the ball sinks. The density of water is equals to 1 gram per cubic centimeter. Which mass of water has entered the ball when the top of the ball is first level with the water surface? Which mass of the water has entered the ball when the top of the ball is first level with the water surface? So if this is the water surface and the top of the ball is level with the water surface, it means that the entire ball is now inside the water. So they're asking which mass of water has entered the ball when the top of the ball is first level with the water surface. Now, for this to happen, for such a scenario to happen, for the ball to completely sink, because if the ball was something like this, then it would mean that only this part of the ball is displacing the water, which would mean that the water inside the ball, or the weight of the ball going downwards, will be equal to the upthrust provided by the displaced liquid. But if the entire ball has just gone inside the water, it means that the weight of the water is at that moment approximately equal to the weight of the ball. Or at best, we could say that at that particular instance, the water inside the ball and the ball itself, its weight, its density, because the only way something can float is if its density is greater than the density of the liquid, or if the density is equal to the density of the liquid. If the density is less than the density of the liquid, then something will sink. So since this is just becoming level with the water surface, so just sinking, it means that in that particular instance, the density of the liquid and the density of the ball plus the water inside of it are equal. Now, in that case, if these two densities are equal, then now we can work out the question now. How do we work out the question? The question is asking us about the mass of water that has entered the ball when the top of the ball is first level with the surface. So we know the density of the water is 1 gram per cubic centimeter. We know that the volume of the plastic ball is 20. So we are going to say the mass of 4 grams of the plastic ball plus the mass of the water that has entered divided by 20, the volume of the ball, should be equal to 1 at that particular instant. In which case, if that's the case, then 4 plus m will be equal to 20 if we multiply both sides by 20. Then I take 4 to the other side. M is equals to 20 minus 4, which is equal to 16 grams. So that's B. Then in number 5, a satellite orbits the Earth at constant speed in a circular orbit. Which statement is correct? Remember, acceleration is the rate of change of velocity, or the change of velocity over time, acceleration. But velocity has two things. Velocity is magnitude and direction. So since velocity is magnitude and direction, even if the speed is a constant, then the magnitude is a constant. But because it is moving in a circle, the direction of the satellite is changing, which means that it has an acceleration. So if you see that all the answers here are talking about the resultant force, resultant force, resultant force, resultant force, resultant force, we know that since we have already established that we have an acceleration because it is moving in a circle, so there must be a centripetal acceleration, there must be a resultant force. If there is a resultant force, then now it's about establishing which one is the answer. Let's start with A. The resultant force on the satellite is 0. No, it cannot be 0 then because acceleration will be 0, and acceleration is 0, then direction or speed will not change. But here direction is changing. I'll go for C. The resultant force on the satellite is away from the Earth. So in other words, it is saying that the satellite which is orbiting the Earth, that's the satellite there. They are saying that the resultant force is away from the Earth. That's not possible because we know that for something moving in a circle, the resultant force and the acceleration is towards the Earth. It cannot be away from the Earth. Then in which case, if it is away from the Earth, it will change the direction to go away from the Earth. So we will not be able to move around in a circle around the Earth. Then D says the resultant force of the satellite is, the resultant force is in the direction of the motion. So if it's in the direction of the motion, the resultant force, then the acceleration will also be in the direction of the motion. So if the acceleration is in the direction of the motion, then it is not possible to move with constant speed. That acceleration will change the speed, but without changing direction. So the speed will change, but direction will not change, and will not be able to move in a circle. Then finally, B, the resultant force on the satellite is towards the center of the Earth. Towards the Earth. That's the correct one. Then the next problem question was number 16. A room is heated by a radiator. The diagrams X and Y show two possible circulations of hot air which heat the room. Which diagram and the reason explain the heating of the room by convection? Which diagram and reason explain the heating of the room by convection? So we are looking for the diagram which explains the heating of the room by convection. Now, of course, it cannot be. When we are talking about convection, we must understand that in convection currents, either we are talking about convection of air or convection of water, of liquid, or of gases. The gases, when they are heated, they rise. This definitely is wrong because it is showing as if the radiator is here, the radiator is heating the gases beside it. Remember, the room is being heated by radiation, but however, they want to know how convection currents are set up. So the radiator, in as much as it produces heat by radiation, the air molecules beside it are going to be heated by radiation. But if the air molecules are heated, the first thing that they do is not moving to the right like that. It's moving upwards because they become less dense, and when they become less dense, they rise up. So the possible diagram is this one, because that's where we have air molecules rising up after the radiation. So answer is A. Diagram X. Air density decreases when air is heated, so it rises up. That's the answer there. Number 17. A student writes down some facts about two transverse waves. Wave 1 has a frequency f and a velocity v. Wave 2 have 4 times the frequency of wave 1 and is traveling at a velocity of 2v. What is the wavelength of wave 2 in terms of f and v? So we have met these questions before. We shall meet them again and again. So we want to find the wavelength of wave 2 in terms of f and v. Now the general equation says wavelength will be equal to the speed divided by the frequency. So for the first instance, we have frequency and speed as v and f. So let's say that this is the first wavelength, or let's just leave it as lambda like that. Now what is happening in the next instance is that now we are told that there is 4 times the frequency of wave 1. So there is 4f, and there is the velocity is 2v like that, which means that the new wavelength will be equal to 1 over v over 2f like that. That's the new wavelength. So that's only logical. That's what it should happen. The wavelength of wave 2 is that one. So it's D. Then the next question is question 29. This one now has 4 diodes. We shall see whether it is full wave rectification. The diagram shows a circuit used to run a DC motor from an AC supply, which diagram shows out the current in the motor. So the answer is either this one or this one. This is for half wave rectification. This is for full wave rectification. So the question for us is to establish whether current will flow through the motor for each instance. So suppose this side is positive and this side is negative. Then what does it mean? Current would flow like this. When it comes to this point, it cannot go this way because there is a diode which is reverse biased. So current would flow in this direction. When it comes here, there's an option to split here, but it cannot go through here because the diode here is reverse biased. So current goes like that, enters through the motor from the top, comes here. It has an option to split here, but this would take it to where it has come from the positive, which is not possible. Current should always flow to the negative, from positive to negative, from a higher potential to a lower potential. Here, the same thing would happen. It would take it here, where it has already passed by. So it cannot go back to where it has passed by, because then it's like water flowing down a high terrain or down a slope. This water, once it has flowed down the slope, it cannot go back upwards on its own, because then that would mean that it is going back to a higher potential. It would need to be added energy for it to do that. So here it comes back to the negative. So let's check the other direction now. If the alternating current becomes positive on this side and negative on this side, then current comes here. It cannot go this way because the diode is reverse biased. So it goes here like that. It comes here. It cannot go back here because the diode is reverse biased. So it comes here, goes down through the motor, then comes here. When it is here, it cannot come back here because then this point is at a higher potential to this point. So goes here like that, comes here, and then goes back to the negative. So we can see that whether this side is positive or whether this side is positive, there will always be a current entering through this motor from the top. So current in the motor is flowing in one direction. At every time, there is never a chance that in the half cycle there is no current. So of the two graphs, then D is correct. Why is D correct? Because D indicates a situation whereby current will always be flowing in one direction, right? Whilst this one indicates that at some point the current will be zero. It's blocked. Okay, so the next problem question was question 31.